right, let's look at number 41 from section 3.5. We're taking the limit as x approaches negative infinity of this function. And if you look at, they give us a hint. They tell us to rationalize a numerator. So if I'm going to rationalize the numerator, what I'm going to do is this. I'm going to put this over 1. And then usually what I did when I rationalized things was I tried to get rid of a radical in the denominator, but in calculus it's often more useful to rationalize a numerator. And what we do is we multiply by the conjugate. Okay? And remember, I've got to multiply this function by 1 or I've changed its value. So that's why I have to put this expression over itself. All I did was change the plus sign here to a minus. Okay? So now what's going to happen is I'm going to get the limit as x approaches negative infinity. And then on the top, remember this is a difference of two squares pattern. So a plus b, a minus b, where the x is your a and your b is this radical x squared plus 3, would be equal to a squared, which is x squared, minus b squared. Well, b is the square root of x squared plus 3, but if I square it, I'm just going to get that expression back. And on the bottom, I've got 1 times x minus the square root of x squared plus 3. Okay, so this ends up being the limit as x approaches infinity of x squared minus, and then when you square that radical, you just get minus x squared minus 3. Remember that minus is going to go with everything inside of that radical, because once you get rid of the radical, it's a x squared plus 3 is, maybe you think of it like in parentheses, okay? Then you can see what's going to happen on the top. X squared minus x squared is going to be 0. Minus 3 is going to be negative 3 on top. So we get negative 3 on top. And then on the bottom, it's going to be just this x minus square root of x squared plus 3. Now, if we're using that idea of Bobo Botten eats DC, we can see the exponent is bigger on top. So there's not going to be a horizontal that would be bigger on top, Botten, B-O-T-N, no horizontal asymptote, no limit is what we're going to find here. So let's go ahead and write down the expression though. If I were to plug in infinity at this case, so it'd be infinity minus the square root of infinity, which is going to be basically negative 3 over infinity. This is going to approach 0. So I guess we could say our limit here, the limit and the horizontal asymptote are not exactly the same thing. Actually, I was wrong when I said this would be a Botten, because if you look at what happened when we got the function in its most reduced form down here, it was negative 3 over all this mess. So it would have been bigger on bottom. That would be a Bobo, wouldn't it? B-O-B-O, which means the limit's going to be 0. So the limit as x approaches negative infinity is actually 0. I misspoke when I said that was Botten, because I was kind of looking here and thinking that the square was bigger than the x to the first on the bottom, but those squares canceled out and added up to 0. So when you look at this function, when I had to really wait to apply that rule till I all the way reduced it there, that negative 3 over all that mess, well then the exponent was bigger on bottom, because we had an x to the first minus, then under the radical you had a square root of x squared, which is going to be some kind of x to the first plus that 3. So if this has actually been bigger on bottom, the limit would be 0. The limit and the horizontal asymptote, really, they are the same thing. Technically they're different, but here when we're just trying to find the limit, we can see that through algebra we can see that it's 0, and it also still does fit that theorem, bigger on bottom. The limit is 0 or the horizontal asymptote is 0. They really are the same thing. I really kind of misspoke there too. Sometimes it's kind of hard to keep it all straight. Let's look at maybe 47. You're going to do 43 just like you did 41, so I'll just skip on to 47. You have the function f of x is equal to x minus the square root of x times x minus 1. And it says in exercise 47 through 50, use a graphing utility. Use your calculator, basically, to complete this table. And they're just basically saying if you plug in an x as different things, 10 to the 0, we know that's 1. 10 to the first power would be 10. 10 squared would be 100. We know what this is. So even though the table says 10 cubed, for instance, we're going to type in 1,000. We're going to want to put this function in our calculator and then go change it to ask so that we don't, you don't want to be scrolling all this way. So what we're going to do is get our calculator. I'm going to leave that for you to do. I'm just going to kind of set it up for you. Type this function in. Plug in, again, that 10 to the 0, remember that's just 1. Plug in 1, put your calculator on ask for independent value. Put it on ask. Plug these values in, and you're going to see what happens. Compare your result, it said, with the estimates. What they're wanting you to do is basically look at the calculator and see what the number approaches. If they wanted you to find it analytically, I'm going to let you put it in the calculator yourself because that's just silly for me to write all that down when you could get it off your calculator. I get a little irritated when people just skip things like this and say, I don't know what to do, because it tells you, use your calculator, and here's the values, the X values you plug in. You're getting the Y values that go with them, and you're putting them here in the table. So I'm not going to I'm going to assume you have more ability than for me to have to do that for you. Let's look at this analytically, though. What they're wanting us to do is just do what we did in number 41. Basically, if we want to find the limit, is x. If you look at this, this is getting very big in a positive direction. So we're looking at the limit as x approaches infinity. And f of x is this x. I'm just going to go ahead and write it here. Minus square root of x times x minus 1. And we're going to do what we did on number 47. We're going to assume we're going to make this a fraction by putting it over 1. And then we're going to multiply by 1. How are we going to pick what we multiply by? We're going to take the conjugate of that top term. We see that this actually does help a lot. Okay. And I got to make 1, so I got to do the numerator and the denominator by that value. Now what we find here should verify what we find in the table. So we should see the same thing happening. We're just doing it when it says analytically, it says do it with algebra, basically. You could change the instructions to mean that. All right, so it's the limit as x approaches infinity. Let's see if I can't get this lay down. All right, so that on the top we're going to have x squared, and then minus the second thing squared would just be x times x plus 1. Because you square the thing under the radical, you just get that back. And then I have this x times x plus 1 on the bottom. Now remember, I don't want to think about Bobo Botten eats DC just quite yet, because if you remember when I was doing 41, I did it a little too early and came up with the wrong result because I didn't notice some terms canceling out. So let's see what happens here. On the top, we're still taking the limit. I'm just going to try to squeeze it in right there. Blah, 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 limit, blah, blah, blah. X squared minus, now if I do this out, this is going to be x squared plus x in parentheses, but that's going to make x squared minus x when I distribute that negative sign. All right, and on the bottom I have x plus the square root. I'm just going to go ahead and say that's x squared plus 1 and multiply that out. I could have done that earlier even if I wanted to. Now what I end up with is the limit as x approaches infinity of a negative x over x plus square root of x squared plus 1. Now if I try plugging in infinity right now, negative infinity, no, this is positive infinity, I'm going to get the indeterminate form infinity over infinity. So I know that's not what I really want to do. If I use the theorem, Bobo Botten eats DC, I can tell that this limit's going to be negative 1. But let's go ahead and just see, let's make sure that's what it is going to be. Because we've got this, under this radical on the bottom, we've got the square root of x squared plus 1. So if you remember, how did we handle this earlier in some problems? What we do is we divide through by the largest term. So let me write the function. I'll just write it a little spaced out like this. And what I'm going to do is divide each term by x. Okay. Now under this radical, I'm going to extend the radical on down. I'm going to divide each term by x. The square root of x squared would be x. So what I'm doing when I do this is I'm dividing each term by x. I actually have to write it as the square root of x squared to get the x under the radical. So what does this simplify to? This is going to be a 1, and that's going to be a 1. And then under here, x squared over x squared is 1. And then 1 over x squared, Okay, so here's what we've got. Let's just keep copying here. X approaches infinity of negative 1 over 1 plus the square root of 1 plus 1 over x squared. Now, let's plug in the infinity and take the limit, because here we're going to see that our answer is changed a little bit. We did have to consider that x squared that was under that radical. We weren't sure at first if it was going to affect it, but now when we do this all the way through with the algebra, we don't make the mistakes that we might do by trying to apply the theorem too early and not being quite sure about what was under that radical. If I plug in infinity, this is going to be negative 1 over 1 plus the square root of 1 plus 1 over infinity is going to go to 0, so 1 plus 0 is 1. That's going to be negative 1 over 1 plus the square root of 1 is 1, so we're going to get negative 1/2 is our limit, which is maybe not what we expected if we had looked a little bit earlier. It wouldn't have been what we would expected if we had, like up here, just decided, oh, this part right here that I'm circling in red over and over again right now, that part doesn't matter. It's just going to be negative x over x is negative 1. Now, my answer is not the same as what's in the answer key, and I'm going to go check that out here in a second, but they have positive 1/2. The thing that I don't understand about if they get the positive 1/2 is we do have a negative. Let's go back up on the use yellow to kind of highlight a green. That'll stick out a little bit better. I had this negative, and I had to apply it to the x squared, so it was a negative x squared. That's what made the x squareds cancel out, and then the negative to the positive x would have been a negative x. Oh, I copied it down wrong. Yay. It was x minus 1. Okay, so the answer key is right. What happened is I thought this was an x plus, and I thought I'd left the 1 off. You can see I went back and put it in red. It's an x minus 1, so it's minus x squared minus x. So that's minus x squared. This term was right, but then it should have been a plus x here. So that made this a plus x. That made this a plus x. That made this a plus 1, because x over x was 1. So there's the plus 1. So it did end up being a half. So it's always a good idea to check your, even I'm still needing to check my answer with the answer key. Usually what happens is, even when you get really, where you can do the algebra on this, you misread something you wrote down. When I work on this iPad, sometimes it's really just hard to, read what I wrote. I thought that was x plus, and I thought I'd left the 1 off, and it was just an x minus 1. So that takes care of why the answer key said it was a positive 1/2. It is a positive 1/2, and we went back and fixed that. I tried to trace back through that in the green just to recap.